Hey, welcome. Today we're going to talk about one of the most powerful tools out there for figuring out the world, the scientific method. But let's forget about the lab coats and the crazy complicated formulas for a second. We're going to look at it for what it really is, a super practical, everyday toolkit for solving problems. Okay, so to kick things off, let's start with a little mystery. I'm sure you've seen this happen before, right? You put an ice cube on a metal pan and another one on a plastic cutting board, and whoosh! The one on the metal just turns into a puddle, way faster. Why is that? It's something we see all the time, but the reason? Well, it's not so obvious. We're going to solve it together. And the best part is, you don't need any special equipment to figure this out. Not at all. All we really need is a structured way to think about the problem, a system, and that system is exactly what we're going to unpack. So let's go ahead and open up that problem-solving toolkit. Our main guide for this whole investigation is going to be the scientific method. Think of it as our step-by-step manual for finding an answer we can actually trust. So what is it exactly? Well, at its heart, the scientific method is just a systematic process. It's a way for us to look into things, to answer questions with logic, and this is the most important part, to test our ideas using actual evidence. The whole goal is just to make sure our experiments are fair and our answers are solid. The whole thing follows a really clear path. First, you start with an observation that makes you ask a question. Next, you form a hypothesis, which is really just your best educated guess. Then you set up an experiment to see if that guess holds up. And finally, you look at the results and draw a conclusion. That's the exact roadmap we're going to follow for our little ice investigation. All right, enough theory. Let's get our hands dirty. It is time for the Great Ice Melt Race, where we're going to take those steps and apply them directly to our question about why that ice melts so fast. First things first, the hypothesis. Now, this isn't just a wild guess. It's an educated guess that predicts what's going to happen. And check out this little trick, the if-then format. It's such a great way to phrase your guess because it makes it super clear and, most importantly, testable. So let's make one for our ice melt race. Using that if-then structure, we can say it just like this. If an ice cube is placed on a metal surface, then it will melt faster than on a plastic surface. See how that works? It's specific, it's a prediction, we can actually test that. Now, we can't just toss some ice cubes around and call it a day. If we want a fair race, a reliable experiment, we have to control the conditions. In science, all those things that can change in an experiment are called variables. Getting them right is the absolute key to getting a result you can trust. This table here breaks it down perfectly. You've got your independent variable. That's the one thing you change on purpose. For us, that's the surface type, metal versus plastic. Then there's the dependent variable, which is what you measure to see the result. In our case, that's the time it takes the ice to melt. And finally, you have your controlled variables, all the stuff you have to keep exactly the same, like the size of the ice cubes and the temperature in the room. So yeah, just to be super clear, the independent variable is kind of the star of the show. It's the one and only factor you're intentionally changing to see what happens. For us, it's all about the surface type. And the thing we're watching and measuring? Well, that's our dependent variable. Its outcome literally depends on the change we made with the independent variable. We're timing the melt because we think the surface is going to affect it. And this part right here is so important. Our controlled variables. I mean, if we don't keep these other factors the same, our results are basically useless. Imagine if we used a giant ice cube on the metal and a tiny one on the plastic. Of course the results would be skewed. That's why the size, the shape, the room temperature, all of it has to be identical. That's what makes it a fair test. Okay, so the race is over. We've run our experiment, keeping everything fair and square. Now it's time for the verdict. What happened? And more importantly, what's the big lesson we can take away from all this? And the results are in. As you can see, just like we thought from the very beginning, the ice on the metal surface melted way faster than the ice on the plastic one. Our experiment officially confirmed what we first observed. We've got evidence. So what's our final conclusion? Well, our hypothesis that the ice would melt faster on metal is officially supported by the data. And now we can finally answer why. It's because metal is a much better thermal conductor. It pulls heat from the air and transfers it into the ice cube super efficiently, much more than plastic does. And that's what makes it melt so fast. Mystery solved. But hang on, what if we'd been wrong? This quote really gets to the true spirit of science. If the ice had melted faster on the plastic, our hypothesis would have been rejected. But that is not a failure, not at all. It's a discovery. It just means we learned something new, and now we can go back and come up with an even better hypothesis. Learning is the whole point. And this all brings us to what I think is the most important part of this whole thing. This process, it isn't just for melting ice cubes or for scientists in a lab. The real magic happens when you realize that your world is your lab. You can use this way of thinking every single day. So if there's one thing to take away from this, is that the scientific method is a universal power tool. It's a way to stay curious, to solve problems big and small, and to make decisions based on actual evidence instead of just a gut feeling. I mean, think about it. You could actually test if those expensive batteries are worth it. Or you could time your commute for a week on 2 different routes and see which one is actually faster. Does that new fertilizer really make your plants grow taller? Test it on one plant and not another, and see for yourself. These are all real-world problems you can solve with this exact same process. This quote just sums it all up perfectly. Science isn't about memorizing a bunch of facts out of a textbook. It's an action. It's about being curious, asking questions, and actually investigating the world around you. So, I'll leave you with a question. Just look around you. What are you curious about? What's some little mystery that you could solve with a simple observation, a good hypothesis, and a fair test? What everyday mystery will you investigate next?